Officially, this aircraft was called the Focke-Wulf 189, but in the Soviet Union it was much better known by the nickname Rama, the Rame, which it received at the front. This versatile machine was used mainly on the Soviet-German front, and it was highly valued both by German pilots and by their opponents. The history of the Rama began in February 1937, when the technical department of the German Ministry of Aviation issued a technical specification for a new tactical reconnaissance and artillery spotting aircraft. In Hitler's Germany, whose armed forces were based on a powerful army, tactical aircraft that ensured its effective operations always received great attention. The Henschel reconnaissance spotter had barely entered military trials when a more advanced machine was already being prepared to replace it. The new aircraft was required to improve practically all flight characteristics compared to the Henschel, along with an increase in useful load, particularly by expanding the crew from 2 to 3 men. According to the military views of that time, the reconnaissance aircraft could also be used as a light bomber and ground attack plane to provide direct support to troops on the battlefield. But above all, the reconnaissance plane needed to provide a good field of view for all crew members and high takeoff and landing performance. The layout of the aircraft and the number of engines were not specified. 3 firms took on the task: Arado, Focke-Wulf, and somewhat later Hamburger Flugzeugbau. The Arado project, which received the designation R198, represented a further development of the same traditional concept, of which the Henschel was a clear example. The R198 was a single-engine high-wing monoplane with a well-mechanized wing and non-retractable landing gear, nicknamed the Flying Aquarium because of the heavily glazed lower part of the fuselage. The machine proposed by Hamburger, on the contrary, looked extremely exotic. It was a single-engine aircraft of an asymmetric design. The crew gondola was built separately from the fuselage. The Focke-Wulf project, created under the overall direction of Kurt Tank by engineer Erwin Kozel, represented a golden middle ground between the first two. It had an unconventional but well thought out and rational layout. The designer's idea went much further than the initial requirements. They wanted to obtain a truly versatile machine by applying a rather original solution. The aircraft had a twin boom layout. Each engine nacelle extended backward, continuing into a tail boom. These booms were connected behind the engines by the wing and at the rear by a horizontal tailplane. Above the wing, along the aircraft's centerline, was a teardrop-shaped fuselage gondola. From the beginning, it was developed in 3 variants: A, reconnaissance spotter; B, trainer; C, ground attack aircraft. Thus, using essentially the same airframe and power plant, it was possible to build an entire range of tactical aircraft. Kozel's design successfully combined modern achievements in aircraft construction with purposeful simplicity. As already mentioned, the twin-boom layout expanded the aircraft's capabilities, but it also provided the crew with excellent visibility as well as lightness and strength of the airframe. The Germans were not pioneers of such a layout. Several years earlier, an almost identical scheme had been used on the Fokker G1 fighter. Kozel, however, created his own version, maximally simple and suitable for production. To begin with, the Focke-Wulf reconnaissance plane was all metal. Only the control surfaces, rudders, and ailerons that were fabric covered. Everything else was made of light alloys. Both tail booms were absolutely identical and interchangeable. They were all metal semi-monocoque structures with stressed skin. The booms had a rounded square cross-section and were attached to the flanges of the engine nacelles at the wing's trailing edge. The engine nacelles themselves were an integral part of the center wing section. The fins were built as part of the booms. Both fins were connected by a horizontal stabilizer. The wing consisted of 3 parts, the center section and 2 outer panels attached beyond the engines. The rectangular center section had 3 spars. 2 of them, the main and the rear, passed right through the gondola, while the swept outer panels had 2 each. The spars were of truss type, built from profiles. The wing's load-bearing structure was supplemented by ribs assembled from stamped parts and by stringers laid along the outer sections. The wing leading edge was hinged to fold open, providing easy access to control rods and wiring. The wing carried ailerons with duralumin frame and fabric covering and metal flaps. The flaps occupied about 1/3 of the span of the outer panels and the entire trailing edge of the center section, continuing under the crew gondola. The ailerons, as well as the elevators and rudders, were equipped with trim tabs with electromechanical actuators. The central gondola, where the crew of the reconnaissance plane was located, was almost entirely glazed. As with all German aircraft of that time, the glazing was divided into a large number of panels, mostly flat. This simplified the production of the canopy and its repair. Moreover, flat glass practically did not distort the view. In the nose on the left sat the pilot. To his right and slightly behind was the observer's position, who at the same time served as navigator, bombardier, radio operator, and gunner. Behind them, the main wing spar passed through the cabin. A reinforced frame connected to it by struts merged into part of the canopy framework. It also served as an anti-rollover frame. The third crew member, the flight engineer, who was also the rear gunner, lay on a special mattress in the streamlined, narrowed rear section of the cabin. The crew entered the aircraft through canopy panels that opened upward above the pilot's and observer's seats, and a similar panel for the flight engineer. For the power plant, the designers chose the new, at that time, 12-cylinder V-type air-cooled Argus engines, each with 430 horsepower, with two-blade fixed-pitch propellers. The engines were enclosed in well-streamlined cowlings. The propeller hubs were covered with conical spinners. Fuel tanks were placed in the forward part of the tail booms. Oil tanks were located in the engine nacelles behind the fireproof bulkhead. The FW-189 landing gear was fully retractable. The main wheels, mounted on separate shock-absorbed struts, folded back hydraulically, retracted into the rear section of the engine nacelles, and were fully enclosed by doors. The tailwheel folded to the left and was flush-fitted into the horizontal tailplane. In flight position, the strut and wheel were also covered by a fairing. For 1937, the defensive armament of the Focke-Wulf reconnaissance aircraft looked very powerful. In the front, to the right, a 7.92 mm machine gun was mounted in a ball mount. A similar firing point was placed behind the pilot's and observer's seats in a recess of the canopy. The end of the nacelle was fitted with an electrified Icaria turret. Its cone rotated with a special electric motor. The machine gun fired through one of the unglazed windows of the cone. For direct troop support, the aircraft carried two fixed forward-firing 7.92 mm machine guns installed in the wing roots. If necessary, they could also be used for defense in the forward hemisphere. Under the wing panels were 4 bomb racks designed for carrying various bombs weighing up to 110 pounds, incendiary devices, or containers for laying smoke screens. The total bomb load was 440 pounds. Of course, the FW-189 could carry a camera. A special bay allowed installation of one of several types of cameras. Additionally, the observer could use handheld perspective cameras. Reliable communication of the crew with the ground and other aircraft was provided by a radio set. Since the aircraft was required to have a ceiling of about 26,250 feet, significant for a machine of this type, an oxygen system was provided, with cylinders located in the wing roots behind the machine guns. The Focke-Wulf project received official approval from the Reich Ministry, which in April 1937 ordered 3 experimental aircraft in the reconnaissance configuration from the company. At the same time, a similar order was given to Arado as insurance. Hamburger Flugzeugbau, which by that time had been transformed into the aviation division of Schiffswerft Blohm und Voss, decided to build an aircraft at its own expense. In fact, it was completed first in February 1938, and after preliminary testing of the prototype by Ernst Udet, a similar order for 3 machines was issued for this aircraft. However, the Arado and Blohm und Voss reconnaissance planes were only considered backup options in case of unforeseen difficulties with the FW-189. The first Focke-Wulf reconnaissance prototype was built in the summer of 1938. It received the designation F-189V1. Since experimental aircraft, even military ones, were at that time given civil registration codes in Germany, the corresponding letters appeared on the fuselage. At the end of July 1938, Kurt Tank himself made its first flight. The aircraft left a very favorable impression: stable, maneuverable, and well-controlled. Tank named the reconnaissance plane the Owl. In August 1938, the second prototype entered testing, and in September, the third followed. Unlike the unarmed first prototype, the second was fully armed. The third again carried no armament, but it had Argus engines in the so-called standard set, and Argus automatic two-blade propellers similar in appearance to the earlier ones. The pitch change mechanism of these propellers was driven by a small turbine mounted on the spinners. The test results of the first 3 prototypes exceeded all expectations. The competitors, however, failed spectacularly. The aircraft built by Arado according to a traditional design approach turned out to be much lighter than the FW-189 and smaller in size. It slightly outperformed the frame in speed and range, but was far inferior in maneuverability. Only the unarmed first prototype took to the air. The unfinished second and third were scrapped immediately. The Blom und Voss reconnaissance aircraft required long refinement to reach an operational state. It turned out larger and heavier than the FW-189A, and although it was the fastest of the 3, its handling characteristics left much to be desired. Only 13 examples of the Blom und Voss aircraft were built. Interestingly, on the very first prototype, the crew nacelle was soon redesigned into an almost exact copy of the FW-189 nacelle. The Reich Aviation Ministry ordered 4 more experimental FW-189s. The first of these was intended as the standard for the series of short-range reconnaissance aircraft, FW-189A. It was built at the end of 1938. On it, the contours of the engine cowlings were changed, the diameter of the tail wheel increased, the movable machine gun in the forward glazing removed, and the main landing gear wheels were made partially protruding from the nacelles. This feature was abandoned in the production series. After completion of factory tests, this aircraft was used for trials of various weapons and equipment, including incendiary devices for spraying poisonous substances and devices for laying smoke screens. The second additional aircraft was a prototype of the training modification FW-189B. It had a completely different fuselage with a traditional stepped nose section, an opaque fairing instead of the tail turret, modified engine cowlings, and a different antenna arrangement. Unlike the FW-189A, which carried 3 crew members, this one carried 5. The aircraft was intended for the training of multi-engine pilots, navigators, and radio operators, and it had dual controls, both from the left and the right front seats. This aircraft carried no armament. It first took to the air in early 1939. The reconnaissance aircraft from the Focke-Wulf company proved the clear winner of the competition, but the German Air Force Command was not in a hurry to put it into mass production. The leadership was completely satisfied with the Henschel 126, which at that time was replacing the old biplane Heinkel 45 and 46 aircraft in reconnaissance squadrons. The Henschel performed quite successfully in combat trials in Spain and overall matched the level of machines of the same class in other European air forces. It is worth recalling that in the Soviet Union, a large portion of artillery spotting squadrons and flights at that time were equipped with biplanes that were significantly inferior to the Henschel 126 in their characteristics. Therefore, the start of series production for the Focke-Wulf reconnaissance type was delayed, and primary attention was paid to the trainer and ground attack variants. Focke-Wulf received an order for a short installation series of 3 trainer aircraft, and then for 10 pre-production machines. 3 installation series aircraft and 3 pre-production machines were ready by the end of 1939 when the Second World War had already begun. Another 7 trainer machines were completed in January-February 1940. These aircraft were delivered to aviation schools that trained bomber crews. A trainer seaplane variant was being developed in parallel. It was the same basic airframe but fitted with 2 large floats. At the end of 1938, construction of an experimental machine began. However, before assembly was completed, the factory received instructions to stop work on the seaplane. The unfinished aircraft was completed as one of the trainer variants. At the end of 1938, the first prototype was taken off flight tests and began conversion into an attack aircraft prototype. The elegant glazed central reconnaissance cockpit was removed and replaced with a steel armored box, much smaller in size, angular, and cramped. The pilot and the gunner were to sit back-to-back in it. The circularly armored cockpit provided good protection for the crew, but working conditions inside it were unbearable. Both the pilot and the gunner could see almost nothing. The pilot could look only forward and slightly to the side through small armored glass panes. The gunner had only a small round firing port under the machine gun. Both crew members entered the cockpit through the armored pilot's hood, which hinged upward and backward. There were no weapons fitted to the machine at that time. The aircraft began flight tests in the spring of 1939. Due to a considerable increase in weight, the aircraft lost noticeably in speed and service ceiling, and even more so in maneuverability. Handling also worsened. Takeoff, and especially landing with very limited visibility, became simply dangerous. The gunner had a very narrow field of view and a small firing sector. The cockpit design had to be revised. The armored box was made somewhat shorter and taller. Larger windows were given to the pilot, and 2 tiny upward and side viewing panes were added. The gunner's round firing port was replaced with a large opening. In this form, the modified aircraft was sent out for comparative trials. Its competitor was the Henschel 129. The latter, from the outset created as an armored attack aircraft, had somewhat better characteristics than the Focke-Wulf with the same engines. It turned out to be more compact and lighter, in part because it was built as a single-seater. The rear gun position of the modified Focke-Wulf proved so ineffective that it was hard to call it an advantage. Although the Henschel 129 suffered from practically the same problems, a cramped cockpit, poor visibility, and so on, it nevertheless appeared more successful than the Focke-Wulf. Nevertheless, another experimental aircraft in the attack configuration was ordered. It differed from its predecessor by more powerful engines of 465 horsepower and variable pitch propellers, as well as new 2-strut main landing gear legs. Armament consisted of 2 20mm cannons and 4 7.92mm machine guns in the wing leading edge, and a twin 7.92mm machine gun for the gunner. It carried a full complement of bomb armament and special equipment, including racks for dispersal devices for chemical agents. In early 1940, this aircraft flew for the first time, and in September 1940, it was sent to the Luftwaffe Test Center. By that time, the Henschel 129 was already undergoing military trials in a squadron. Although frontline pilots uniformly and loudly cursed the Henschel, the ministry decided that the machine could still be refined. The fact that the Henschel 129 turned out to be substantially cheaper than the Focke-Wulf attack variant also played a role. Production of the latter was finally abandoned. That was the end of the attack variant story, although some of the design solutions proposed for it, in particular the new strengthened landing gear and the gun installation, were later applied to the reconnaissance machines. An order for series production of the reconnaissance main variant was issued only in 1940. Already in February, the Bremen Focke-Wulf plant began assembly of 10 pre-production reconnaissance aircraft. From the summer, the first production machines followed them. Compared to the prototype, the production aircraft differed by a new type of landing gear and more powerful engines. By the end of 1940, 20 production reconnaissance aircraft had been assembled, which made it possible to conduct military trials in a training squadron. Alongside the reconnaissance machines, several trainer aircraft were also operated there from the spring. At this time, great importance was attached to increasing the production of the Sov, as this aircraft was nicknamed. The point was that Henschel 126s, which had operated quite successfully in Poland in the autumn of 1939, suffered heavy losses during the French campaign. Production of the reconnaissance aircraft in Bremen seemed to be getting underway, but at that moment the Focke-Wulf 190 fighter began to enter serial production, taking up an ever-increasing share of manufacturing capacity. Therefore, the main order for the reconnaissance aircraft was transferred to Czechoslovakia to the Aero plant in Prague. At this enterprise, the cockpit, central wing section, and tail booms were manufactured, and the overall assembly was carried out. The CKD Prague plant supplied the wing panels and horizontal tail unit. In 1941, more reconnaissance aircraft were built in Czechoslovakia than in Bremen. A total of 151 and 99 aircraft respectively were completed that year. At the end of 1941, production from Bremen also began to be transferred to France, to the plant in Bordeaux. By this time, the new German Focke-Wulf reconnaissance aircraft began to enter Luftwaffe combat units. However, at the moment of Germany's attack on the Soviet Union, none of these aircraft were yet in combat squadrons. They appeared at the front only in the autumn of 1941. Although losses of the older Henschel reconnaissance planes were relatively small, less than those of the more modern Messerschmitt fighters and Junkers bombers, the vast scale of the Soviet-German front and the intensity of combat operations had their effect. Within a short period, the Germans lost more than 80 Henschels, including 43 irrecoverably. Moreover, the Henschel was already out of production, and reconnaissance squadrons began to be reinforced with the new Focke-Wulfs. The 1st Reconnaissance Squadron received new Focke-Wulfs in November 1941. It was not completely re-equipped with new aircraft, retaining part of its older Dornier bombers. Shortly afterwards, Focke-Wulfs arrived at other reconnaissance units that worked with Army Corps and supported tank divisions. The transfer of aircraft into both long-range and short-range reconnaissance showed that the Luftwaffe command had not yet determined in which role it would be most advantageous to employ this aircraft. From this point, the creation of the truly legendary reputation of this very skillfully designed machine began. The feedback from Luftwaffe flight and ground personnel about this aircraft was exclusively favorable. Reliability, ease of piloting, and technical maintenance and maneuverability were its distinguishing traits. A highly valued characteristic of the aircraft was its high stability, which was at the same time combined with excellent controllability. The Argus engines started wonderfully and worked like clockwork. Moreover, the failure of one engine posed practically no threat to the crew. The aircraft could fly perfectly well on the one remaining engine. The survivability of the Focke-Wulf was very high. Being a rather difficult target thanks to its high maneuverability, the aircraft could withstand a large number of hits from bullets and shell fragments. There were even cases when the aircraft returned to base after a ramming attack. Even before the aircraft appeared at the front, it was decided to strengthen its defensive armament. From the second half of 1941, improved Focke-Wulfs began leaving the production lines, equipped with twin machine guns in the rear mounting. In 1942, a similar installation was introduced for the upper gunner's position, with the overall ammunition load more than doubling. At the end of spring 1942, the most famous short-range reconnaissance group, Tannenberg, received 3 improved Focke-Wulfs. Soon, these aircraft demonstrated their survivability. On May 19th, a pair of Soviet MiG fighters attacked a lone Focke-Wulf, flying over the Taman Peninsula at an altitude of 13,000 feet. The Soviet fighters hit the left engine of the unusual enemy, watching with satisfaction as after several bursts, the engine nacelle detached from the aircraft. Confident of victory, the MiGs departed, but the German reconnaissance plane still managed to make a forced landing at its forward airfield. In the summer, the Focke-Wulfs appeared over the most remote sectors of the Soviet-German front. In the July report of the Air Force of the Karelian Front, these aircraft were described as training machines used for military reconnaissance. But such complex definitions appeared in documents only briefly. More and more often, the Focke-Wulfs were being employed at the front. 4 detachments, reorganized from long-range into short-range reconnaissance, were equipped with them, strengthening the Air Force. On the axes of the main German offensives, Soviet soldiers knew the Focke-Wulfs well. "Cursed planes," wrote General Fedor Polonich Polonin. From dawn till dusk, they plowed across the Soviet sky, searching for targets to strike, watching the movements of Soviet troops. Usually, reconnaissance observers at an altitude of about 3,000 feet tracked the movement of infantry and tanks, detected reserves, corrected artillery fire, photographed aircraft stands, anti-aircraft guns, depots. The reconnaissance planes operated in practically any weather conditions, and if air defense resistance proved strong, they climbed to altitudes up to 10,000 feet. On August 25, 1942, anti-aircraft artillery shot down a Focke-Wulf. The pilot of this aircraft, Feldwebel F. Elkerst, was one of the first to be interrogated in captivity. Despite his youth, 22 years old, he had considerable experience, having begun fighting back in France. The prisoner reported that from the airfield at Olshancy near Orel, their unit conducted reconnaissance with accompanying bombing in the Kirov-Jizdra-Sukinichi triangle. In a day, 5 to 6 flights were carried out, almost always without fighter cover. In 3 months of combat, there were no aircraft losses. One of the pilots was seriously wounded, but he still managed to return to his own lines. Elkerst considered the main reason for such successful actions to be good coordination with observation posts, which allowed them to avoid encounters with Soviet fighters. At this stage of the war, combat losses were insignificant, while aircraft production continued to grow. In 1942, significantly more Focke-Wulf reconnaissance planes were built than in the previous year. At the Aero Company, 183 aircraft, in Bremen 57 and in Bordeaux 87. By September 1942, the latter plant had reached a level of 20 aircraft per month. At this time, the Focke-Wulf was the most widespread short-range reconnaissance aircraft in the East, with 174 units, compared to 103 Henschels and 40 Messerschmitts of various modifications. On such key sectors of the front as the Stalingrad area, German reconnaissance crews literally hung over Soviet positions. For example, over Mamayev Kurgan, they appeared 5 to 6 times a day at intervals of 2 to 3 hours. Each sortie of these aircraft was usually accompanied by an attack from dive bombers. Despite the cunning of these twin-engine aircraft, Soviet pilots gradually learned to intercept and shoot them down. Thus, on 18 September 1942, fighters of the 237th Aviation Regiment broke through to a reconnaissance aircraft that was being covered by a flight of 4 German Messerschmitts. After attacks by Ivan Balyuk and Yakov Mikhailik, the German airplane caught fire and lost its left wing, and 2 other Soviet pilots finally finished off the Rama. German documents later showed that the crew was killed in that sortie, Oberfeldwebel Kohle and Feldwebel Leska. The pilots of the 237th Aviation Regiment had another victory over these aircraft above Stalingrad. On 17th of December 1942, over Davidivka, Sergeant Ivan Chumbarev rammed an airplane. In the ramming strike, his Yak-1 only slightly damaged its propeller, and he safely landed at his own airfield. However, the German crew led by Oberfeldwebel Meyer, although wounded, managed to return to their 16th group. During the Soviet counteroffensive on 19 November 1942, the Ramas, based on improvised forward landing sites close to the front line, suffered most from actions by tank and cavalry units. Aircraft were destroyed on the ground. A month later, the total number of short-range reconnaissance aircraft on the Eastern Front had been reduced from 294 to 238. Losses in some squadrons sometimes exceeded the number of aircraft remaining. For example, one squadron had lost 6 of the 7 aircraft it possessed in mid-November by the end of 1942. About 150 short-range reconnaissance aircraft, mainly these twin-engine machines, for various reasons remained forever in the Volga steppes. It is not surprising that after the capitulation of the 6th German Army, the reconnaissance groups were disbanded. It turned out that although these aircraft were more survivable than earlier models, they could operate successfully only under conditions of air superiority. Having assessed the changed situation, the German command abandoned plans for the complete re-equipment of military aviation with Ramas. At the beginning of 1943, reconnaissance groups were reinforced with fighter reconnaissance aircraft and other types. New tactical methods were urgently developed for the remaining aircraft. Emphasis was placed on cunning and surprise. The North Caucasus Front report for March 1943 noted that Ramas lured patrols of Soviet fighters into their area to be struck by superior forces of Messerschmitts. Great attention was paid to thorough knowledge of the area where reconnaissance was to be conducted. Replacements were introduced into service and spent at least 10 days studying the combat area. Usually, each squadron operated in its own narrow sector along a well-studied route. The successes of military reconnaissance in spring 1943 were due both to excellent training of pilots and navigators. For example, in one squadron of 8 pilots, there was 1 captain, squadron commander, and 5 Oberleutnants. Each had more than 500 flight hours. It should be recalled that in the Luftwaffe, pilots typically graduated from flight schools with the rank of non-commissioned officer. In May 1943, these aircraft debuted in a new role for them: anti-partisan operations. The German command recognized the great usefulness of these aircraft during punitive actions in the rear of Army Group Center. However, a month later, all twin-engine reconnaissance planes were back at the front and took an active part in supporting Operation Citadel. For Soviet pilots, these aircraft in 1943 remained a difficult but honorable trophy. Many fighter pilots agreed with the opinion of General Boris Mikolayevich Yeremin. To be sure of bringing this aircraft down, you had to fire at the cockpit. But with the Rama's remarkable maneuverability, it was not easy to do. That's what happened. I perforated one of the beams with bursts. Glazov managed to open fire, but apparently you had to literally cut through the beam for the Rama to fall. The Nikolai Yevanovich Glazov mentioned in this episode was one of many who later died fighting these aircraft. On the combat record of the excellent pilot, hero of the Soviet Union, were 475 combat sorties, 13 enemy aircraft shot down personally, and 5 in a group, when on 30 June 1943 he encountered a German reconnaissance aircraft. A similar encounter for Volodymyr Dmitrovich Lavrenenkov ended on 24 August 1943 with a parachute jump over territory occupied by the enemy. Soviet aviation specialists awaited the test results of the Rama at the Air Force's Research Institute with interest. Here are some conclusions from the report on this aircraft. The twin-beam layout is one of the most successful for an aircraft of the military reconnaissance type and for an artillery fire observer. It provides excellent visibility, convenient for crew work, is easy to fly, and allows flight on one engine. The accessibility and replaceability of units and their operation make the aircraft simple to maintain and easy to master. It is sufficiently and fully equipped with all necessary equipment for flights in difficult meteorological conditions. But it was also noted that the presence of only small caliber weapons and weak armor protection for the crew makes it possible to destroy these aircraft not only by fighters, but also by attack aircraft and frontline bombers. The Germans understood this too, so at the end of 1942 they put into production a modification in which the wing machine guns were replaced with cannons, and armor was installed in the lower part of the fuselage, under the engines and fuel tanks. This modification was preceded by a version with duplicated flight controls from the observer's position. Mainly these machines were used in training units, in particular when mastering radio direction finding. Many aircraft were converted for special purposes. In 1941, several Ramas were adapted as personal staff transports. For example, one was used by Field Marshal Kesselring and another by General Jeschonek. In February 1943, the factories in Bremen and Prague stopped producing FW-189 aircraft, while in Bordeaux, France, 194 machines were assembled within a year. In France, an attempt was made to launch their own reconnaissance variant under the name FW-189E, equipped with French Gnome-Rhone air-cooled radial engines. Their takeoff power of 700 horsepower almost doubled the capacity of the previous engines and allowed for a significant improvement in the flight characteristics of the aircraft. A similar re-equipment had been successfully carried out on the HL-129 ground attack aircraft. However, the French FW-189E project failed. During testing, the prototype crashed and the project was never resumed. The FW-189F modification proved more successful. The F1 model received boosted engines with a takeoff power of 580 horsepower. Plans for the FW-189F2 included reinforced armor, increased fuel capacity, and changes to the electrical system, but these improvements were never completed. By the end of 1943, 5 FW-189F1 aircraft were built in Bordeaux, and another 17 were assembled in early 1944. The final modification of the Owl was the unrealized FW-189G project, which included a number of design changes and even more powerful 950 horsepower engines. The factory did not manage to complete even a prototype of this series before the war ended. In the spring of 1944, the Frames were still actively engaged in combat on various sectors of the Eastern Front. Many units had up to 1,000 successful combat sorties, although the number of Focke-Wulfs was steadily declining. For example, in the 6th Air Fleet, as of April 10, 1944, Groups 4, 10, 15, and a separate detachment had only 42 FW-189 short-range reconnaissance aircraft. 2 more aircraft of this type had been converted into night interceptors. The Luftwaffe Command never found an effective way to counter the light U-2, PO-2 aircraft. Heavy night fighters such as the Ju-88C and Bf-110G proved ineffective against them, as they were much faster and less maneuverable. Therefore, several FW-189A1 aircraft were equipped with Liechtenstein radar and a heavy-caliber machine gun mounted obliquely upward-forward through the slot of the removed upper turret. These machines were used on the Eastern Front in a night fighter detachment. They were last recorded in service at Greifswald in February 1945. Unfortunately, the results of the FW-189's work in the role of night fighters remain unknown. In the summer of 1944, the fascist leadership came to another conclusion. The Frames, even with strong fighter cover, could no longer conduct daytime reconnaissance. Numerous Soviet interceptors regarded them as target number 1 and tried to shoot them down first. The surviving Focke-Wulfs were assigned a new role as night photo reconnaissance aircraft. After being equipped with standard cameras and illuminating bombs, the FW-189 was quite successful at night, thanks to its ease of piloting and good takeoff and landing characteristics. At the same time, the flat panel glazing, set relatively far from the pilot's eyes, similar to the Ju-88, caused inconvenience and complicated night orientation. By the end of March 1945, night reconnaissance detachments were still operating. About 50 frames ended up in the hands of Germany's allies. The Slovaks were the first to receive them in the winter of 1942-43. The Slovak Air Force was supplied with 14 Akira FW-189A1s for the 1st Reconnaissance Squadron, among other German aircraft. This unit was almost continuously stationed in Crimea until its evacuation in April 1944. During the Slovak National Uprising, the Reconnaissance Squadron, based at Triduby Airfield, supported its forces but without much success. By the end of August 1944, the last 6 FW-189s had flown over to the USSR. The Hungarians made the most extensive use of the frames. They received their first 14 aircraft in the spring of 1943 to replace obsolete He-46 and WM-21 aircraft in the squadron. This unit was commanded by Captain Laszlo Telbis, who, operating from Kharkiv Airfield, began flights against partisans in May 1943 when the first Hungarian frame was shot down by partisans on May 22nd. By the beginning of the Battle of Kursk, the squadron had already completed 224 combat sorties. The most successful engagement occurred on September 21, 1943, when Lieutenant Bela Chapeau managed to fend off 3 Yak-9s. One was shot down by the gunner, another crashed after breaking off the attack, and the third withdrew after exhausting its ammunition. The Hungarians also suffered losses, and by March 1944, only one serviceable frame remained in the squadron. The unit was disbanded. However, soon a new squadron was formed under Captain József Fraunhofer. The Focke-Wulfs cooperated with the 1st Hungarian Army, and in battles near Zamość they quickly lost 10 out of 14 aircraft. 5 were shot down by fighters, 1 crashed during a landing in bad weather, and the rest were destroyed by ground fire. By the end of the war, the squadron was in the process of rearming with Bf-109s. In 1943, both Bulgarians and Romanians received several frames. The latter used them to retrain flight crews. In Kirovohrad, the Focke-Wulfs helped the crews of the 8th Assault Air Group master the HS-129, while in Arad and Tete they were used for training crews of night fighters and reconnaissance aircraft. The Romanian frames were not repainted but retained their German camouflage and fuselage codes. After Romania declared war on Germany, one of these aircraft was transferred to a research institute for study. Until recently, many articles on German aviation equipment ended with a phrase such as, "Most of the aircraft of this type were used on the Soviet-German front and were destroyed by Soviet pilots." But in the case of the FW-189, this is precisely what happened. In the West, until the Allied landings in Normandy and in North Africa, only one detachment still had frames. Of the 864 FW-189s built, including experimental modifications, nearly half were lost in combat, and their main opponents were the Red Star fighters and ground attack aircraft. Although few of these machines survived, they justified most of the expectations placed upon them. Even after completely losing air superiority, the fascists tried to keep this aircraft in service until the very end. You can say that with the end of the war, the history of this outstanding aircraft did not finish. In fact, when 10 years after the creation of this German aircraft, the Soviet Su-12 artillery spotter and short-range reconnaissance aircraft was being designed, and 30 years later, the American OV-10 Bronco, designers in Moscow and Columbus, arrived at a result remarkably similar to what their German colleagues in Bremen had obtained in 1937. The fuselage is an all-metal structure consisting of a central cabin and 2 separate tail booms. The engines and main landing gear legs are located in the forward sections of the booms. The crew cabin is divided into a central section, nose glazing, a rear intermediate glazed section, and a tail section with a gun turret. The frame of the nose glazing is made of steel tubing. On aircraft up to the 100th serial, the frame was made of a light alloy. The glazing is made from flat sheets of transparent plastic, all equal in size. One of the upper left panels was made opening, the so-called bad weather window. In the floor to the right of the observer's seat, there was a hatch for photography with a handheld camera. Metal grills were installed above the lower glazing to prevent the transparent plastic from being pressed in by feet. The frame of the nose glazing is attached by bolts to the first structural ring of the central section. The load-bearing structure of the central cabin consists of 10 structural rings and several longitudinal beams and is skinned with duralumin sheets. The central part of the cabin is bolted to the central portion of the wing. The main and rear longitudinal spars of the wing's central portion run across the cabin, remaining unchanged in height. For access to the cabin, 2 transparent hatches that open upwards are provided in the top of the central section, and in the lower part there is a sliding vent window for cabin ventilation. Both hatches are equipped with emergency jettison devices. The pilot's height-adjustable seat is formed by metal panels. The seat was mounted to the first and third structural rings. The seat height adjustment lever was installed on the right. The travel of the seat in height was approximately 6 inches. A parachute was placed in the seat pan. On the starboard side, between the first and fifth structural rings, there was a rail to which the observer bombardier's movable and swiveling seat was attached. The upper part of the central cabin section is transparent. The rear rotating gun turret with full 360-degree traverse was bolted to the fuselage. The turret drive is electric. Retractable telescopic steps were fitted to the lower rear part of the cabin to ease boarding. The steps are electrically driven. The rear air gunner was seated on a special mattress. The tail booms are circular in section and interchangeable. Each boom was assembled from 2 halves joined together with bolts. The forward end of the boom was attached to the engine nacelle with 32 bolts. The front and rear ends of the boom had reinforced flanges. The tail unit was attached to the rear flange with 16 bolts. The small cross-section of the tail booms provided an increased firing sector for the defensive armament mounted in the central cabin. The 3-axis wing with a working, load-bearing skin had a rectangular central section to which the crew cabin was attached. Engine nacelles were located at the junction of the central section and the outer wings. The central section had main and auxiliary longitudinal spars. The wings had a dihedral of 5 degrees. The wings were bolted to the central section. Between the 5th and 6th transverse beams, provision was made for the installation of bomb carriers. The wing's load-bearing structure consisted of a main and 2 front and rear auxiliary longitudinal spars, stringers, and transverse beams. The wing mechanization included flaps and 2-section ailerons. The main sections of the flaps were located on the lower surface of the central section between the crew cabin and the tail booms. Each aileron section was hung on 2 hinges. The aileron section framework is metal, the skin is fabric. The inner aileron sections had ground-adjustable trim tabs. The aileron deflection angles were plus 20 degrees. The landing flaps are divided into outer and inner sections. In the takeoff position, the inner flap sections deflect 15 degrees and the outer 8.5 degrees. In the landing position, the inner sections deflect 60 degrees and the outer 40 degrees. Each section is actuated by an electric drive and a system of push rods. The flap retraction and deployment lever is installed in the cabin to the left of the pilot's seat. There is an illuminated indicator of flap position. The control system has both rigid and flexible wiring. Steel cables actuate the ailerons, elevator, and rudder. The wiring to the rudder is duplicated to increase combat survivability. All control surfaces have independent wiring. In the main reconnaissance variant, a massive control column with a yoke is installed in front of the pilot's seat, offset slightly to the left of the aircraft longitudinal axis. Rudder control is bipedals. The tail unit is all metal. The rudder can deflect up to 30 degrees and down to 28 degrees. Structurally, the rudder is divided into 2 interchangeable parts, right and left. The rudder frame and the leading edge skin are metal. The skin of the other parts is fabric. In the midsection of the elevator, there is a trim tab whose installation angle is changed in flight by an electric drive. The fins of the aircraft cannot be interchanged. They are attached to the tail booms with bolts of about 1/3 of an inch in diameter. The rudders can deflect left and right by 30 degrees. After modernization of the internal equipment, the rudders became interchangeable. The framework of the rudders and the covering of the front part were made of metal, while the rest was covered with fabric. Each rudder was suspended on 2 hinges. Heavy counterweights were installed in the upper part of the rudders for balancing. The rudders were equipped with trim tabs. The right one was used only for static balancing, while the angle of the left one could be adjusted during flight with the help of an electric drive installed in the left fin. The landing gear of the aircraft was retractable. The main struts were identical and interchangeable, equipped with oil-air shock absorbers. The struts retracted into special bays behind the engine nacelles, rotating backwards in the direction of flight. Retraction and extension were carried out by hydraulic actuators. The frame of the main strut was made of I-beam profiles of magnesium alloy. The wheel rims were made of magnesium alloy, the tires measured 30 by 11 inches, and the tire pressure was 83 pounds per square inch. Splash guards were fixed above the wheels. The wheels of the main struts had independent brakes powered by the hydraulic system. The brakes were controlled by the rudder pedals. In the cockpit, there was a light indicator for the landing gear position. The lamps were installed on the left side of the instrument panel. When the main struts were extended, a green lamp lit up. There was also a light indicator for the position of the tailwheel strut. The tail strut was attached to the front and rear spars of the horizontal stabilizer. The strut retracted by turning left into a special bay inside the stabilizer with the help of a hydraulic actuator. The tail strut could rotate 360 degrees when extended. The tailwheel rim was made of steel, the tire measured 14 by 5 inches, and its pressure was 43 pounds per square inch. A two-section shield was attached to the right side of the tail strut, covering the landing gear bay in the retracted position. The hydraulic extension time of the landing gear was 13 seconds and retraction took 8 seconds. The power plant included two 12-cylinder air-cooled engines with a power output of 465 horsepower at 3,100 revolutions per minute. The engine torque was transmitted through a reduction gear to a two-bladed wooden variable pitch propeller with a diameter of 8.5 feet. The engine was attached to the engine frame. Each nacelle was equipped with two remotely controlled fire extinguishers. Fuel tanks were located in the engine nacelles directly behind the bays of the main landing gear struts. Each nacelle contained two fuel tanks with a capacity of 29 gallons each. The tanks were bolted to a platform that could be easily removed through the landing gear bay. The fuel tanks were separated from the engine by a fireproof bulkhead. The tanks were equipped with a low fuel warning system for 15 minutes of flight. Two warning lamps were installed on the left side of a narrow instrument panel fixed at the top of the cockpit. The engine was started by an electric starter or manually by ground crew using a crank inserted into a socket on the left side of the nacelle. The ignition system was manufactured by a German company. The starter switch was located on the console to the left of the pilot's seat. The hydraulic system was used to extend and retract the landing gear. It had right and left circuits, independent of each other. The left circuit operated the left main strut and the tail strut, while the right circuit operated only the right main strut. The landing gear control lever was mounted to the left of the pilot's seat. The crew cabin was equipped with a heating system. Hot air from the engines was supplied through pipelines to the crew stations. In addition, hot air was directed to the leading edge of the wing to prevent icing. The high-altitude equipment included an oxygen system. Oxygen cylinders made of light alloy were located in the wing in front of the main spar. All crew members had oxygen masks. For launching signal flares, an opening was made in the cockpit floor, and the flares were stored on the right-hand wall of the central nacelle. The onboard rations were stored in 5 cylindrical containers attached to the rear of the left side. Flight and navigation instruments were mounted on a narrow panel fixed above the pilot's head. A magnetic compass was installed in the left bay of the main landing gear strut, with its indicator located on the instrument panel. On a small panel installed between the pedals on the cockpit floor, there was a backup compass and engine revolution indicators. The radio equipment included a receiver, a transmitter, switching devices, and a signal converter. The receiver, transmitter, and switching equipment were placed behind the pilot's seat, while the converter was installed in the left wing plane. A directional frame antenna was mounted under the central nacelle, and a mast for a tensioned wire omnidirectional antenna was mounted on top. Some aircraft were equipped with transceiver radio stations. The photo reconnaissance equipment consisted of a stationary camera fixed in a vertical position on a massive frame and a handheld auxiliary camera. Various models of aerial cameras were used as stationary ones. The cameras were mounted in the central part of the nacelle directly behind the main spar of the center section, shifted to the left side. The opening and closing of the lens cover and the film feed were operated by electric motors. The operator manually set focus and exposure and also determined the frame rate. The handheld camera used photographic plates measuring 3 by 4 inches or 5 by 7 inches. The container with the handheld camera was mounted in front of the main spar of the center section. The armament consisted of machine guns and externally mounted bombs. Within the thickness of the center section of the wing, on the sides of the central gondola, one fixed forward-firing machine gun of 7.9 mm caliber was installed on each side. The machine gun barrels were inserted into special tubes that reduced weapon fouling. Behind the main spar, there was an ammunition supply of 500 rounds for each machine gun. Spent cartridges were ejected through openings in the skin of the lower wing surface. Fire from the fixed machine guns was controlled by the pilot. A ring sight was mounted in the cockpit at the pilot's eye level, and the machine gun trigger was located on the right horn of the control wheel. A movable defensive machine gun was mounted on a traversing turret of the upper hatch installation. Double drum magazines for the machine gun, 5 units, were stored on the right side of the cockpit in the area of the gunner's seat. Another double drum magazine was attached to the left sidewall. Another machine gun was located in the tip of the central gondola and fired through a sliding hatch. An ammunition load of 5 double drum magazines was placed in the left and right parts of the tail cone. Spent cartridges from the machine guns were collected in rubber containers located under the cockpit floor. The typical bomb load included 4 bombs weighing 110 pounds each, which were suspended on bomb racks installed on the lower surface of the center section. A bomb sight was fitted for the bombardier. Bomb release could be carried out by either the bombardier or the pilot. Provision was made to suspend smoke generators on the bomb racks for laying a smoke screen.